Alright, so today, at least the goal, is to work a little bit on Hecke. So I need to figure out, God, what am I typing? I need to figure out essentially some things about this code base so that it's not totally wackadoodle. And I kind of want to rearrange some of my files. So this is no longer, I think, a helpful directory. I don't know if it matters. Anyways, so one thing that we want to do is go and clone a very certain directory from GitHub repository. Okay, and then we're gonna open up, wonder if this is gonna work. I'm actually not sure how to, let's see, minus to go up a directory. Or rename as sort by X special. And F1 for help. Is it easy to go into a directory? So T? Or parenthesis maybe? So let's do this, I guess. Oh, just type it in. No, that's not right. Right, so we're still learning. And now I'm wondering if I... Man, how do I go down a directory though? Maybe just enter. Oh man, it's so simple. And then just, I didn't make any file, right, okay. So, the directory that I was looking at, it's effectively, okay, actually one thing that we should check out is this. Nope. God, I knew that was gonna happen. So I wonder how to exit a file and go back into file system. It's not exactly. So let's try. Okay, now how do we zoom in? I tried doing control minus for some stupid reason. But now control plus doesn't exactly want to do anything, so we just go to the help, right? And I want to actually search So let's search the help. And we're going to look for zoom. Locally modifying comments. Zoom. Minimus zoom. Zoom in and out of a buffer, making it full screen in a floating window. I don't think that's the right one. Scale. Enlarge font. Size. We could even just search I was gonna say we could just actually search something like this. Fuck. Okay, what's the other thing that we want to go? Exiting or going back? Okay, so let's try Control 0. That was good enough. And now we're gonna search the help. And what are we looking for? We're looking for how to go in and out of file trees. So if I have a file, how to go back to a directory listing. Okay. Anyways. Okay, let's try this. So we're gonna go down to this, and then there's apparently a command like that. Ooh. Does that close anything in the background? I don't know if this would actually let me see it in the first place, but kind of don't think so. Alright, so let's go here, and then this was one that I wanted to mess around with. So looking at the documentation for quaternion algebras, this is something that I think would be really simple to to adjust. So it says at the moment field must have characteristic not equal to 2. And so that's something that we're going to try to fix. So okay. Kind of want to do this. Then, just to have this in a in a new window. So when we run, when eventually we want to test. So actually, let's just try testing right now. So we're going to use Hecke. Let's try installing. Also, let's see what version we're at in this. Okay, 0.36. Which is the right one, almost. I mean, so the latest is one up, but am I supposed to use it from the directory? So, quit. Exit. Fuck. Exit. CD Hecke. I think I'm supposed to install the package somehow, like add the package. From a directory. So we're going to exit again. And just go to Julia, which we were just in. Here, dev, and then current directory. So let's actually exit and CD1, and then go into Julia, dev. Okay, so effectively step 1 is just actually play around a little bit with the quaternion algebra functionality in this package and see what really needs to be added first. So we've got a quaternion algebra function which calls field K. It's going to return quaternion algebra formed from field K and these two elements, A and B. I think that A and B should be checked to be not, Oh, this is actually just a constructor function, huh? So we're gonna try K is QQ, and we'll do quaternion of QQ and see if this works. Oh, it did. Okay. So if I do I plus j squared, that doesn't do anything. I think I need to import the generators then, if that's true. So let's do A is quaternion algebra QQ -1 -1. And now let's try to figure out what this should be. Okay, so a Hecke-quaternion algebra is a multiplication table given by an array. So we want to know what we want to go, let's see. Okay, so one thing that is nice about having the terminal open inside of here is the easy switchability between the two. So maybe I will try doing that. Exit. So here, we'll open up the terminal. Open up Julia. And that's it for now. So escape, escape. Right, we want to search for something like generators. So how do you actually go about finding oh, so it's some kind of array like this, huh? So we have to call the algebra with an array of elements. Huh. Parent call overloading. A quaternion algebra of A where something. Get 1. Order type. Okay, so if I just say Q, so in case we don't need this. So Q is going to be quaternion algebra. Let me So now I is supposed to be QQ of an array 0, 1, 0, 0. Sorry. Just one Q. Fuck. So what if I just say, like, I don't know, X. Okay, then X is J. So now I plus X squared is -2 to the 23rd. Okay. So that's totally fine. I wouldn't mind if there's a function that just outputted the variables. But quaternion algebras can be loaded in with these arrays. I don't necessarily give a shit. So let's see. It's not exactly how some of the other stuff in Oscar works, like the free associative algebra or polynomial rings. So, how do you call a univariate polynomial ring? Okay, but now I can just use like x squared, and then x is just an element inside of R. I kind of like that about this. It should be clear that you know what. It should be easy to. I mean, there should be no problem, I think, doing like. So if you do something like q dot I, like this should have some kind of this should have some kind of way to get, because when you print out q at the moment, it actually says that it's defined by I squared, but if I do I squared, then I don't, sorry, if I do J squared, because I haven't defined it, then, yeah, it's not clear. Okie doke. So I don't know what this JL doc test is. Let's just ask Gemini. It's probably something to do, like, if I actually call on this, is this something that I'm gonna get? Let's switch up the music. I don't really want to do this either. Okay, so I want to know what this does, for example. So let's look up also what is LM in algebra. We'll find out what that function does. So return elements x with absolute trace reduced norm less than with absolute trace of the reduced norm of x less than or equal to b, including 0 up to sign. Okay, so it's annoying that, to me, it's annoying that, should always clarify that, but it's annoying that quaternions don't come with an automatically just adjusted set of generators. We're not going to require that the characteristic is 2 anymore. I'm going to change this. What is this, huh? So, we're gonna do, if the parents are both K. I think triple K is like on the nose K. Okay. So I'm actually kind of curious now. Because it'll something like this, right? What is the type of this. Okay. Okay, it's not hard to do this for characteristic 2. So, how do you indent an entire block in NeoVim? So, let's try just doing something like this, and then, ooh, that's nice. Okay. So I want to Z is going to be quaternion algebra. Z dot base ring is K. Z dot multitable is M. Z dot 1 is this, and Z dot standard equals A comma B. The hell is that? Oh, this is oh, okay. So if I do like quaternion algebra 2, 3, now Q dot standard is 2, 3. Okie doke. But I think one thing that is interesting, do I need to do this, for example? So, let's try defining a quaternion algebra 0, 0. That was totally valid. Right, that's what we didn't want, I think. Okay, so let me just try starting. Let's just try to break some stuff. Fuck, what was the characteristic call? How do we redo? Control R. I realize now that Julia doesn't want that. And it doesn't give a shit about this. Okay, we're just gonna go up. Go to the end. Go up. Yank. Go like 16J, 7J. So if this is true, then we should require that A and B are not 0. So the @rec macro was used before. We'll just write an assert, I guess. Is there an assert in Julia? Over here has no field 0. Yeah, that's definitely not what I wanted, but Okay. And then, let's see, so the multiplication is a little bit different here. So for quaternion algebra, let's pull up our files and go to the Gilles and Samueli book. So we're going to use this as a source for some good information. Either this or my own notes or some combination of the two are books out there. So I remember there being a characteristic 2 section to some extent. I mean, I'm pretty sure I know what the formula is for this, but I just don't want to fuck it up for some reason. The same. Okay, and I'll try to verify it. So, if you take any element of your field A and any non-unit B, the formula should be that I squared plus I is A, and J squared is B, and I times J should be what? I times J should be like I times J should be J times I plus 1 or something like that. That one I actually don't know. All right, so here we go. IJ is Ji plus J. Actually, somehow got it. Okay, so let's see if I'm understanding this right. Then this should still be true. So these are supposed to be multiplication tables. So this is like, right, 1 times 1 is 1, 1 times I is I. So the second component is like a basis element, and then third component is like the structure constants, I think. So this will be 2 times 1. So this will be I times 1, and that's supposed to be I. Why is there a 1 here? Okay, we need to look up the kind of the way that these are defined. So let's minimize that. Pull this over here. So quaternion algebra is defined as some abstract associative algebra, but I think it's defined through structure constants, structure constant algebra. Okay, this is actually something else that we should look at. So if we go here, see, this should have returned something. Okay. Also, this interface is totally fucked now, right? Oh, actually, I just had an idea. So let's do, if I just, I think I should do this first and then do this. And then, Julia. So we want to figure out what this is. So it's mutable struct. Ay. Q dot, what am I looking for? Multiplication table? So, let's see. I'm trying to figure out how the fuck this multiplication table works. This is 1, this is 1, this is 1, and this is 1. And then this made me think that this almost makes me think something like I times 1 is 1 times I. I times I is A times 1. I times J is 1 times IJ. I times IJ is A times J. Okay, so I think we got it. All right. That is kind of fucked. So I'm going to actually just put that in there. Write it like this. I think that's probably right. And so let's just verify. So this should be it's j times I, and that's minus ij. Right. Okay. So this was all for, I'm retarded. That was all for this top one. Okay, and now, all right, characteristic 2. Ooh. Okay, and so what do we want? We want 1 times 1 is 1. 1 times 1, or sorry, 1 times I is I. 1 times j is j. 1 times ij is ij. I times 1 is 1. I times I is this actually doesn't work, right? Can I do like 1 plus 2? This is the element in this array. Okay. We also need right. So we also need M2 2 2. And that's supposed to be, so I times I is technically I squared plus 1 should be, sorry, I squared plus I should be A. So it's minus I plus A. Is that right? Yep. So minus 1k. Do we have to do it times? No. And now right, I times j is, this is also not true anymore. So what did we say it was? I times j is j times I plus j. That one's a little bit tricky. So, all right. So what is this? What should this be? I times j is just ij. That's right, actually. Is 1 times ij. I times j is ij. That's what I just said. I times ij. So now, what would we actually get here? So this would be I squared, which we said was minus I plus a times j, which is minus ij plus aj. So I times ij. How many j's do we have? Well, a of them. And how many ij's do we have? Minus 1 of them. I feel like this is going to be retarded. In the sense that, yeah. Okay, so we're going to go from here to the end. Yank that. Go down. And put it. Undo that. Put it. And now I want to delete from here to there. Okay. 3, we've got j. So j times 1 is j. J times I is it's ij minus j. So how many ij's do we need? 1. And then we need m3, 2, 3. Should be minus 1. And then how many of these do we need? J times j. That actually is just b. J times ij. J times ij. Ugh. Okay. That's conjugating I. So what should I get? I plus 1, I think. Let's see. So j times ij, that's the same as j times ji plus j squared. Okay, so I got that wrong. So bi plus b. So there's BI. And then M3, 4 should also be B. Okay, IJ times 1 is IJ. IJ times I is something. So IJ times I, this is JI plus J times I. This is JI squared plus JI. That's J times A minus I plus IJ minus J. Or what could we have done here? JI. Just leave that, so we just get AJ, right? I feel like I should actually fact check myself there. Yeah, this is just AJ. Okay. What about here? IJ times J. This is equals BI. That one's good. And then IJ times IJ. Let's use some of these shortcuts that we've written down so far. So this is I times BI plus B, which is BI squared, A minus I, plus BI. So that's just AB. So JIJ is BI plus B. And I squared is A minus I. That's true. A minus I. Okay. So in this case, characteristic 2, it doesn't matter if we have an A, if we have a A here or not. So let's just leave it like this. No minuses. So we're in characteristic 2. Okay. And that's it. Sure, that just broke a bunch of stuff. So let's see. So let's look for standard form. Pretty IO, standard form. Print quaternion algebra, AB over this thing, defined by this. So we should actually change this. Okay, so let's try a new terminal. Julia. Using this. We're going to try returning algebra. And now we want to do Q dot, so okay. Okay. Okay, so let's see. So I should fix this too. How do I put a line at the end? Put a line after. In NeoVim. Oh, is it just O? Probably need that here too. So this one I don't really get. Ooh, actually. Yeah, I thought so. So that's not true. Oh, it's because I renamed J like an idiot. Yeah, that shouldn't be allowed. Fuck. Yeah, it should just be IJ, right? So this is what I would think. This is what I think it should be. Yeah, I don't know. So I think that there should be a way to call generators for the quaternion algebras that kind of like automatically put It seems fucked that you can call like j is equal to I and I is equal to j. So it would probably be a bad idea to put like I wonder if you can make a function that calls a global variable. Also, I'll be right back. Okay, so I want to know if we call help on this, what do we get? This is the doc for right, let's try just let's just try returning this. So we're going to exit, clear. We're going to go into Julia. We're going to use Hecke. Pre-compiling is good. All right, so one thing that we want to figure out is how do we set up a function field. Got a strong feeling that, I don't know, gonna break some tests before we actually figure out what we're doing. Okay. So let's do this. Let's do that. And then let's try see if function field is a term. Function field. Return the function field to which a divisor belongs. What about rational function field? No documentation. Rational field? We have to figure out now in the source. This feels like should be related to the abstract algebra package, so I feel like it's actually going to be really difficult to figure out what we're supposed to call here. Oh, it could be, actually, it could be Nemiko's. So let's try this fraction field of, what were the things that we defined before? Fx? Okay, let's try it. Now we'll call quaternion algebra over K with yeah 1 1. And we'll do I wonder what happens if we do this. Okay. I think this looks nicer than that. So I'm actually gonna edit this afterwards to remember that. And let's see, so we can try just again, now with 0. Search an error. A can't be 0, B can't be 0. Okay, that's a little bit of an error. So our field K has 2, right? Yeah, okay. Shit, I guess we just do this. Okay, I think this is interesting. This does not do what I thought it did. So we want to throw an error if this is not true. Oh, actually, let's just undo that. This is supposed to be a not equals. And then let's go back down here and make this more compact. This is a type of type hierarchy, right? Spanning. Actually, I think actually the type is owned by Hecke, so maybe it's not type hierarchy. All right, so what were we doing? Ooh, okay. It's kind of neat. The tiling manager just totally fucks up all of this. So okay. That's good, right? Yeah, I just want to add one more thing, which is like, I mean, I'm actually kind of curious about this. I just want to know, like somehow include the variables into the namespace. What is V? V is a dot coefficients. A is some element. Coefficients. So what? We're looking for the essentially the data stored by elements in this. Don't think it's in here. One thing I would say is that it's a little bit slower than I thought it would be. So this is something we should try. Just run the same functions that we had before. Q. Okay. I'm curious, does this produce something? It does. 1 ij and ij. So, could try something like this. Ooh, that's kind of funny. I guess there's no real reason for that. For a new function to do this, I guess. It's just how it is. Okay. Some things that I wonder, so this we have to kind of fuck with a lot of this stuff. I don't want to do a lot of the reduce trace and things yet, just because some of these things I really don't want to do. This should be an error. Okay, but it just ran. God damn. Hey, Cha-Cha. God damn, that printed a lot of shit. I don't necessarily understand why. I mean, it's fine. It's not anything, really. You wanna lay down, bud? Okay, so what are we gonna do? We're gonna try to go through the rest of this file and just see if there's anything that really needs to be changed. To incorporate characteristic 2. So, seeing it like this and then seeing it before, it was kind of better before, wasn't it? Okay, so there's a standard involution on a quaternion algebra. The fuck does this function do? So it takes standard involution of quaternion algebra. If it's defined, then it returns else. It defines it to be this. Okay, so we gotta find the underscore underscore standard involution. So this function here, so conjugate, return the image of A under the canonical involution of the quaternion algebra. So we need to triple standard. Why is this in here? This should always be 1. I think. Oh, it's because the basis function does some random shit, right? No way. Does it store it after it calculates it? Yeah, that's some pretty weird error. Ugh. Okay, let's try to see. Also, let's try to run this one. So, I think we should restart this, but Q. I feel like we should restart this just because. Let's redefine this. This should just search, right? Quaternion algebra has no field gens. Given a K algebra, return a subset of basis which generates A as an algebra. If the error search is true, the number of return generator is possibly smaller. The gens function computes additional data for expressing a basis as words in the generators. So I'm wondering, is this a, I wonder if this counts. Will it return true? Really? Ay, ay, ay. I think I get it. Okay, so I'm trying to figure out just at the moment. Do these actually print? So wait, I've been not calling it like this. So and I know this is not what it told me to call. This is actually not. I mean, this is some nonsense, right? Yeah. So I think for Hecke.jl, there's a lot less resources, which make it difficult to actually ask Gemini something about it. I don't know if that's a good explanation, but that's my theory. Okay. Okay, there's actually something that I am interested in. Let's save this for the moment, and then exit, go to Julia. Okay, I'm just annoyed a little bit, but I can get over it. And the reason why I think I'm annoyed is just because I think there are some things that don't make sense to me. So let's see, function standard evolution of A. What are we doing here? Okay. So we're trying to think about, at the moment, just why some of these things are like this. So conjugate, defined as a function, it returns the standard involution of the parent of A. That's fine, I think. And then when it calls that, it goes to this, so function standard involution of this guy, which returns this. What's the point of this? What is the point of having this function here? So then you have a function, standard involution, with 2 underscores in front. You start with a basis. If the basis is nice, then you do this third standard involution because you know what is supposed to happen. So this is what's a little bit annoying. So we have to check on how we even find a basis, huh? So that is this function. So when you call basis on an abstract associative algebra, first checks if it's defined. It'll return that. Otherwise, it'll start with some undefined vector. If A is a group algebra and A is sparse, and for G in the group of A, you pick I to be element index AG, and you set B of I to be A of G. So you just pick a group algebra. Else, for I between 1 and dimension of A, Z is some vector. Again? For j in wanted dimension of a, zj is 0. Why all that extra stuff? And z join I is 1 base ring of a. Okay, so maybe I do see what's supposed to happen. So it's reinitializing a 0 vector each time. And then it's picking essentially the next one, so it's iterating over these guys. And I guess it has to do this because you wouldn't want to just write that z is a vector of 0 base ring. It's not clear if you can do that, I guess. But for quaternion algebra, there's no need for all right, so if is 1, yeah, when does this condition fail? I guess is one question. This seems to always be true with quaternion algebra is constructed using this quaternion algebra function. Okay, in which case it should just return triple underscore. And so this should be standard involution of underscore a. Underscore a is a to a, change basis. A to b. So down below there's just a change basis function, huh? So standard involution. N is dimension of a. O is 1. Assert is 1, basis a. N is the 0 matrix. Base ring N, K is base ring, B is basis. Assert is 1. Okay. Well, that's manageable. So we just have to change this function. Pretty sure. Also, we need to look and make sure that some of these formulas still hold true. But I think that's not too hard. So I'm gonna quit for today, I think. And I'll maybe come back on later tonight, but I have to make some dinner. It's 6:30 here. So thanks for joining me. See you again always.